Welcome back, geometry students. What we're going to be doing today is actually getting into some of our trig ratios. And so today we're going to actually talk about tangent, which is one of our trigonometric ratios. And then in the next video, we're going to be talking about sine and cosine. So hopefully, I don't know how much experience you have with trig, but this will be, if you have zero, this will be a good introduction. So I'm on page 259 of your student journals, section 9.4. And so we're going to start by just kind of defining what a trigonometric ratio is. So basically, when you think of trig, we think of like three different things. We think of sine, cosine, and tangent. And so what a trig ratio is, well, a ratio of lengths of two sides in a right triangle. So it's a ratio of the lengths of two sides, so just two of our sides, in a right triangle. All right, so what we're getting at here is the fact that, okay, so like tangent, for example, and we abbreviate it with tan. So tangent of an angle. And so a lot of times what we use is something called theta to represent an angle. And generally what that means is just, it's almost like it's like using a variable, like x or y, for example. But we're going to use this Greek letter called theta to be able to kind of determine that's the unknown angle in a diagram. So a lot of times in math we use Greek letters to represent angles, and then we use kind of like variables, x, y, and so forth, to represent side lengths. All right, so let's say, for example, I have theta. Theta is this acute angle in your triangle. It doesn't have to be this one, could be this one. Doesn't really matter. So what we really want to know is, what does tangent represent? So tangent is like an operation. It's something you're doing to an angle, okay? So it's kind of like, taking something and square rooting it. Like if you had 25 and you were taking the square root of it, right? You would take the square root of 25. Square root just by itself doesn't really make any sense. You're not just going to write down square root equals something else, right? So similarly, tangent has to follow those same rules. So like tangent doesn't exist by itself. It's tangent of something. So tangent of an angle in a right triangle is the relationship of the opposite side over the adjacent side. So basically there are three parts to your triangle. Well, there are six, counting all the angles, but three parts to the side. So wherever you put your angle, okay, so I put my angle down here, the leg that's next to the angle is called our adjacent side. So adjacent kind of meaning next to, it's the angle that, or the leg that's next to your angle. And the one that's right straight across, so like if you drew a line and went straight across, that side right here, this leg is called our opposite leg. And then if you know anything about right triangles, you know that the longest side of the right triangle is called the hypotenuse. We also know that it's the one across from the right angle. So what tangent represents is a ratio of an opposite side over adjacent side. So as an example might look like something like this. I'm going to write it down here. Let's say I give you a right triangle and I say this is 25 degrees. This is 12, and I say find x. So what we use our trig ratios for is to help us to solve for sides and angles. So what you would do is you would say, okay, here's my angle. Let's label our sides. Well, here's my hypotenuse, because it's across from the right angle. This has to be my opposite, and this has to be my adjacent. So because you're given the opposite and you're trying to find adjacent, opposite and adjacent, you know you're going to be dealing with tangent. So in this case, we're going to be dealing with tangent of 25, because that's our angle. So we named what theta was. So tangent of 25 is opposite over adjacent, so 12 over x. And then what we're going to do is, this is a nice unit kind of following our similarity unit, because we did a lot of proportions and solving proportions in the last unit, and that's what we're going to be doing here. So a lot of times I think of this as just a proportion. So I make a 1 under it, and then I cross multiply. So what I want you to remember is that tangent of 25 is just a number. It's like saying the square root of 25, kind of. It's a number, right? And so it's not a variable, even though there's letters there, right? T-A-N, it's not a variable. It's an operation. So what we're going to do is we're going to actually end up doing this in our calculators. So I'm going to divide both sides by tangent of 25. And so let me show you how you would do that in your calculator. So first and foremost, if you notice, we measured our angles in degrees. So your calculator, and something you'll probably get into more next year than this year, but your calculator can measure, we can do angles in both what we call, well, degrees, but also another unit of measure called radians. So what I want you to do is hit your mode button. So it's kind of on a TI-80 something, it's right kind of located towards the top. Do you see how down here on like the fourth line, see where my calculator has degree highlighted? You need to have your degree highlighted because all of the angles we're going to be dealing with are going to be in degrees. So make sure that your calculator's in degree mode, otherwise you're going to get all the wrong answers and then you're going to not understand why things aren't working out for you. So just make sure that your calculator's in degree mode. So if it's not in degree mode, just put your cursor on degree and hit enter, and that should bring you to the correct mode. All right, so let's do the math. We're doing 12 divided by tangent of 25. So literally it's kind of written as it would look, right? 12 divided by, and then tangent. You see where your sine, cosine, tangent? So these are the abbreviations for sine, cosine, and tangent. That's not sin, it's sine. Anyways, you're going to do tangent of 25. And so this would be the side length we're solving for. So that would be x. So x is going to equal 25.7, we'll say. And so what we're asked to do here and why we're learning these ratios is that the trig ratios are all different ratios that deal with different kinds of relationships in a right triangle. And so today we're just focusing on tangent, but then we're also going to focus on sine and cosine tomorrow and another day. All right, so the last thing I need you to understand, a couple things I need you to understand. So first of all, I'm going to go back to this theta. So remember, theta could be up here. So just to kind of give you an example, let's say I gave a right triangle and I made theta, let's call this, let's put theta here. Let's put our, our angle here. And let's say I made this 15 and this is 12. So what I want you to understand, if you were labeling your sides, now this is going to be your opposite side, right? Because it's across from your theta, your angle. And then this would be your adjacent side because it's next to your angle. And then this would be your hypotenuse, which is across from your right angle. So if we change where theta is, then obviously the side that's opposite or adjacent are going to change. What you might notice is the hypotenuse leg never changes because it's always constant. It's always that side that's, across from the right angle in your right triangle. The other thing I want to mention is that theta has to be acute. And that should make sense. Remember the triangle sum formula, which says that all three angles of a triangle add up to 180 degrees. So if this is 90, then there's only 90 degrees left for the other two angles, which means these have to be acute. So that's another thing to kind of keep in the back of your head, that those have to be acute. All right, the other thing I want to show you is something called angle of elevation. And so a lot of times what we talk about with an angle of elevation is, we'll do like kind of a story problem where we'll say there's a tree and you're you want to see how tall the tree is, so you attach a string from the top of the tree down to the ground. And you want how tall this tree is. Say your the string is 20 meters from the edge of the tree. So this is 20 meters long. And you want to figure out this. And a lot of times what you'll see in a story problem is they'll say the angle of elevation to the top of the tree is 32 degrees, for example. That's what we're referring to here, this is your angle of elevation. So your angle of elevation is always, so imagine it this way. Imagine you're kind of standing or looking, right? And you're looking straight out, so like a horizontal distance. And you're like, oh, look, there's a plane in the sky, and you look up. That angle that your eyes travel is called your angle of elevation. And then likewise, since we're here, we might as well talk about something called an angle of depression. So let's say there was, a bird in the tree and it was looking down at a worm on the ground, right? So the bird is looking and then it's looking straight across. That's like its horizontal distance. And if you're looking on the ground, you would kind of drop your eyesight, right? So that angle is your angle of depression. So this angle right here would be called your angle of depression. And then this angle over here, this small acute angle, is called your angle of elevation. So I need you to notice a couple things about this. So first and foremost, the angle of elevation is always an angle that's inside of your right triangle. So notice how this one's inside. Your angle of depression is outside of your right triangle. The biggest mistake I see is that people label this angle up here, this little acute angle up here, as the angle of depression, and that's not true. So the angle of depression is like imagine you're looking straight out and looking down to the ground. It's this distance here, that degrees. The other thing I want you to notice, this is a little review from first semester. If we have this line, which is our ground, and then we have a horizontal distance at the top, we can assume those are parallel, right? Well, what kind of angles is this angle of depression, this angle of elevation? Anyone know? If you guessed alternate interior angles, you are correct. And what do we know about alternate interior angles? They are congruent. So what that means, if I'm giving you the angle of depression is 32 degrees, essentially I'm also telling you the angle of elevation is 32 degrees. So because they're, different story problems or whatever can give you different information, make sure you kind of understand they're basically one and the same. Just the angle of depression is that angle outside of the triangle, and the angle of elevation is on the inside of the triangle. All right, let's do another example. This time I'm going to do a right triangle. I'm going to give you 2, and then I'm going to make this 30 degrees. So we're going to learn about something called we learned about something called a special right triangle, right? So we've already talked about special right triangles. So we already know how to figure out these side lengths. So remember, this was our 30-degree angle, which means that this has to be a 60-degree angle, and then this would be our short leg and our long leg and our hypotenuse and all kinds of fun things like that, right? So another way of doing this, okay, so preferably we'd like you to use your relationships, right? So from the hypotenuse back to the short leg, you would divide by 2, and then from short leg to long leg, you would multiply by √3. So 1 times √3 would be √3. So what I need you to understand is that you could also use trig. Like if I wanted to figure out tangent of 30 degrees, I could do, like if I wanted to figure out, let's say I didn't know the long leg was √3. And I said, okay, tangent of 30 degrees is opposite over adjacent. So I could do 1 over x and solve for that missing side length. So the trig ratios, whereas the special right triangles have a specific pattern for specific kind of right triangles, like the 30-60-90 and the 45-45-90, the trig ratios were like this, we call it SOHCAHTOA trig, hold true for all right triangles. So you can still use this right triangle trig, like the tangent of 30 degrees, to figure out your answer. However, most of the time, especially in my classes, I will ask you to, if you're given a special right triangle, that you need to use the relationships of a special right triangle. So some way I get around that is by asking you to leave your answer in reduced radical form, which means I want your answer as √3 and not whatever the decimal for √3 is. So, something to consider. I wrote out this story problem, and you don't have to copy it down if you don't want to. You can just kind of follow along. If you want to copy it down, feel free to pause the video and write it down. All right, so I just kind of wanted to give you an example of a story problem that would involve tangent. So it says you're measuring the height of a tree, you stand 40 feet from the base of the tree, the angle of the elevation to the top of the tree is 65, find the height of the tree to the nearest foot. So again, kind of one of these things where, I always think a diagram helps. So like what we were doing before, this is the distance you're kind of standing away from the tree, this is your angle of elevation, that's that little angle down here, and you're finding x. So what I did is I did tangent of 65 is opposite over adjacent, so opposite over adjacent, and then I figured out it's about 86 feet for that length. So again, just kind of showing you how we can use or set up a story problem involving tangent. All right, let's actually go ahead to page 260, which is just some extra practice. Okay, so we're going to go through some of this stuff, and kind of going to do the same thing as I did in the last video, which is I'm going to do part of them, and then you're going to do, well, hopefully you can try the other ones, and then I'll give the answers at the end of the video. All right, so let's do number 1. So this says, find the tangents of acute angles in the right triangle. Write each answer as a fraction and as a decimal rounded to 4 decimal places. I'm going to be honest with you. I don't really care about the whole 4 decimal places thing. I would prefer you write your answer as a reduced fraction. Now, that doesn't mean that Big Ideas doesn't care about it. So, be prepared to do both. All right, so this is what it means. The acute angles in my triangle is, obviously this one's a right angle. S and R are my acute angles. So we need to do tangent of R and tangent of S. So they want us to do tangent of both of our acute angles. All right, so remember, tangent is opposite over adjacent. So that's what tangent equals. So if I'm starting with R, what's the side opposite of R? Well, if you look right straight across, it's 45. And then what's the one that's adjacent? So in this case, it would be 24, because 51 is your hypotenuse. All right, then you need to reduce your fraction. So I'm going to reduce this to 15 over 8. And then if you wanted to follow the directions exactly, let's take it to 4 decimal places. This one actually only has 3, but we can add a 0 to make it 4 decimal places. So that's what it would look like. Tangent of S, opposite over adjacent. Notice the difference here. They're just reciprocals of each other. So if I take tangent of one acute angle in a right triangle and then take tangent of the other acute angle, they're reciprocals of each other, which means this is 8 over 15. And then if I did the decimal approximation, I got 5.333, rounded to 4 decimal places. All right, not a whole lot in terms of what I'm asking you to do here is, again, same kind of deal with 2 and 3. You're just asked to find the tangents of both of those acute angles in each triangle. So I'll save those for you guys to do. Now let's look at 4, 5, and 6. So let's do 4. I'll do 4 and 5, and you can try 6 on your own. All right, so here's 4. So you see that we have this acute angle here given. So this is the angle we're going to kind of reference everything based off of, right? Because we know this angle. Now, you could also find this angle up here, right? Because you know if this is 90 and this is 10, doesn't this have to be 80? Now, that's not wrong to do it that way, so you can reference everything off of that angle. However, it's just not necessary. So instead of, giving yourselves more work to do, might as well just use the angle that's provided. So in relationship to 10 degrees, 5 is my opposite side and x is my adjacent side, which makes this third side here my hypotenuse. Okay, so what we're doing here is we're solving for x. So I'm given my opposite side, I'm solving for my adjacent side. That's how we know we're going to use tangent. Now, obviously, in this section, we're only using tangent, but once we learn sine and cosine, you're going to have to decipher when to use sine versus cosine versus tangent. All right, so tangent of 10 degrees would be opposite over adjacent. I'm going to go ahead and cross multiply. And so this means I'm going to divide both sides by tangent of 10. So 5 divided by tangent of 10, and I get 28.4. Has to round to the nearest tenth. For number 5, same kind of deal. Here's your angle this time. You are given your opposite and adjacent. So if I set up my tangent ratio, so tangent of 64, opposite over adjacent would look like this, x over 13. Because my opposite side now is my x. All right, so if I cross multiply, all I'm really doing here is just multiplying those two things together. So on my calculator, I'm going to do 13 times tangent of 64, and I get 26.7. All right, I'm going to let you guys try number 6, and then and we'll come back to that at the end. All right, last one is number 7 says in the triangle CDE, E is 90 degrees, and tangent of C is 4/3. So what I'm asking you to do here is to draw a right triangle, okay? And so CDE, has to be your right angle. So CDE, in order for them to be in order, it needs to go CDE. Well, I guess it could go CDE. It doesn't really matter. So I guess you put C and D wherever you want. So tangent of C, so if I have my C up here, is 4/3. So what I'm telling you here is that this is my opposite side and this is my adjacent side. So if this is my angle C, okay, my opposite side is 4 to angle C and my adjacent side is 3. So it says find tangent of D. Well, we already kind of know how to do this one, right? So remember we talked about up here, if you have tangent of 2 acute angles in the same triangle, they're just reciprocals of each other. So technically tangent of D without having to even draw the triangle, we could tell you it was 3/4 because it's reciprocal of that one. Or you could look at the triangle and say, okay, tangent of D, opposite over adjacent, and get 3/4. All right, on the next page, we have a few others. I'm not going to do all of these. Again, what they're asking you to do here is kind of some story problems. So I would expect that you would try some of these things on your own. So that way you can, verify that you're getting the right answers. So what I'm going to do is let you try the rest of these on your own, and then I'm just going to go ahead and provide you with answers. So if you want to stop the video now and try the rest, because I think it's important that you try some of these things on your own, and then stop the video and then come back, unpause the video, and I'll give you all the answers to those problems. All right, welcome back. So hopefully you did try all the problems, and let's go over all of the answers so you can see if there's anything additional that you would like maybe to bring to class to go over. All right, so let's start with number 2 at the top. I'm just going to put a line here just so I can tell the difference. All right, so for number 2, I got tangent of J to equal 7/5, and then tangent of L to equal 5/7. So you can do the decimals on there if you want, it doesn't really matter. On this one, I got tangent of A to equal 2/√2, but we need to rationalize that. And so if I rationalized it, I got it to equal √2. And then I got tangent of C to equal √2/2. So please leave those as fractions. That's why I like to leave them as fractions better. All right, number 6, I got X to equal 39.9. Okay, so if you didn't get that, just kind of circle the ones you didn't understand, and then those are the ones I would probably recommend going over in class. All right, number 8, you tried this story problem, so hopefully you set up a tangent ratio. I got X, so I labeled this as X, by the way, and so I got X to equal 83.9 feet. On part B, kind of same deal, I got X to equal, so I got the final answer to be 39.6 feet. That was the difference between the two. So when they asked you for like the distance across the river, later on when it was a year later, I got that ratio to be X to equal 123.5. And then I just took those two answers and subtracted them to get 39.6. Number 9, I got X to equal 97.5 feet. And then number 10 was probably the hardest. I did a lot of Pythagorean theorem and a lot of tangent ratios, but I want you to see if you can even if you didn't get this answer, I'd like you to see if you can come up with the right answer now that you know it. So the perimeter I got in decimal form is 59.3 units. So try this one, okay? And this is one that maybe we can go over in class because I think that would be a good one to kind of go over. But if you can get the right answer, kudos to you. All right, I think that's it for 9.4. We'll talk about sine and cosine in the next video, and so then that'll kind of complete our tangent ratios. All right, thanks for joining me. Go practice on your own. Bring any questions you have to class. Bye for now.